Flutter uses a declarative UI model. That means the interface you see on screen is entirely driven by changes to underlying data. When that data is temporary and only matters to a single component, like the toggle of a checkbox or the current frame of an animation controller, we call it ephemeral state. App-wide state is different. This is persistent data that permeates your entire application architecture, like a user's authentication status or cached network responses from an API. If you try to manage simple ephemeral state using complex global providers, you unnecessarily bloat your application's architecture. When you elevate a simple local variable into a global provider, you force Flutter to perform unnecessary validation passes on the entire widget tree. This waste of CPU cycles is why poor state categorization leads directly to dropped frames and unmaintainable code. The 2026 Flutter ecosystem has evolved well past the idea of a single best solution. Beginners are often met with a wall of jargon and conflicting community advice. This chart shows the massive adoption scale of the top state management packages in 2026, with RiverPod at over 1.5 million downloads, Block at 1.4 million, and Provider holding steady at 1 million. The community is highly fragmented. These packages aren't actually competing to do the exact same thing. They represent entirely different philosophies for handling how data moves through your app. The core dilemma for developers is the fear that picking the wrong package today will force a massive, expensive codebase rewrite tomorrow. Choosing a state management package is actually a business decision. You are weighing long-term scalability against immediate developer velocity. We start with Provider. It remains the official Google-recommended starting point for developers learning how to share data across the widget tree. As this documentation shows, Provider is the simple, officially encouraged baseline built directly on top of Flutter's native inherited widget. Provider requires very little boilerplate code, but carries an architectural flaw when scaling massively. It's tightly coupled to the build context. Data only passes downward hierarchically, making complex logic and testing awkward as applications grow, and you end up with deeply nested providers. On the other end of the spectrum is GetX. This is an all-in-one micro-framework that prioritizes blazing fast development speed and rapid prototyping above all else. Warning tone. But GetX relies heavily on global singletons. Without strict discipline, this reliance leads directly to tightly coupled, untestable spaghetti code. Provider and GetX prioritize immediate developer comfort. That makes them highly effective for minimum viable products, but risky for large, multi-developer enterprise applications. To solve these structural issues, the original author of Provider completely rewrote it, creating RiverPod 3.x. Looking at RiverPod's core concepts, the defining feature is that providers are declared as top-level variables. They are not tied to the build context, completely decoupling your state from the widget tree. Because these providers are global variables, the Dart compiler can verify type-safe access before the code even runs, preventing the fatal runtime errors common in legacy provider apps. RiverPod also natively handles asynchronous data, giving you built-in offline persistence and automatic retry logic for failed API calls. The primary trade-off is a steeper initial learning curve. To keep boilerplate code low, RiverPod relies heavily on code generation tools, which takes time for a team to adapt to. RiverPod offers the highest return on investment for most teams, balancing rigorous enterprise-grade safety with modern developer ergonomics. For highly regulated industries like banking and healthcare, Block is the undisputed corporate standard. Block operates on an event-driven concurrency model. Strict inputs, called events, go in, and highly predictable outputs, called states, come out. The cost of this perfect traceability is volume. Block requires writing massive amounts of boilerplate code, making it overkill for small to medium applications. At the very edge of performance optimization is Signal's 6.x. This imports a reactive approach directly from web frameworks like Solid.js. Signals enforce surgical rendering. Instead of standard widget tree rebuilds, Signals bypass the framework's reconciliation algorithms entirely to update only the specific mathematical value that changed on screen. Block and Signals are highly specialized tools. You pay their complexity tax only when your product requires absolute auditability or maximum frame rate efficiency. To end the analysis paralysis, you have to stop evaluating packages based on hype and map your choice directly to your project constraints. This flowchart maps out the ideal paths. If you are a solo learner or building a quick MVP, follow the path to local state and simple providers. You avoid fighting third-party abstractions and get to market faster. If you are a standard startup or a scaling team, standardize on RiverPod. It ensures a highly testable codebase that can grow with your feature set. For enterprise teams with compliance requirements, adopt Block. It guarantees unbreakable separation of concerns and perfect operational traceability. Matching the package to your specific team size and business goal is the only way to ensure the long-term survival of the project. Once you choose a path, commit to it. Mixing and matching global state managers within the same project creates severe cognitive load for your developers. Regardless of which package you select, you must isolate your business logic from the presentation layer. Standardizing on a new pattern does not mean starting over. Clear, documented migration paths exist between all the major packages. For 90% of new projects in 2026, RiverPod 3.x is the safest, most capable middle ground available. Building a resilient application requires more than picking a popular library. It depends on whether the mechanical strengths of your state management framework actually align with your organizational requirements for testing and scalability.